Okay, so this video is on the Rank-Nullity Theorem, and the Rank-Nullity Theorem, if you've kind of like mastered a lot of vector spaces and work with vector spaces, then the Rank-Nullity Theorem is, it seems kind of obvious, and it makes a lot of sense, and it ends up being pretty handy. Okay, and we're going to talk mostly. Now, I'm not going to really prove the Rank-Nullity Theorem, but I am going to talk about some of the upshots of it and how we end up using it a little bit. Okay, so first, the definition. We'll get the definition of the nullity of A is the dimension of the null space, and we write the nullity of A as the null of A. Then second, we got a second definition. This one's you've heard before a lot. The rank of A is the number of non-zero rows in the row echelon form of A. Okay, so the rank nullity theorem then just says let A be an n by n matrix. Then the rank of A plus the null of A equals n, which is the number of columns in A. Okay, that's it. All right, so we take the rank of A, we add it to the dimension of the null space, and we get the number of columns in A. So suppose that we have the matrix A, okay? And in order to confirm the rank nullity theorem, right, what I want to do is I want to find the rank of A and the null space of A. And then finding the null space of A will give me the nullity of A because it will tell me the dimensions of the null space of A. Okay? So I'm going to take the RREF of A to find both of those. And the RREF of A is going to end up being 1, 0, 0, 10 over 7, 0, 1, 1/3, 5/21, and then 0, 0, 0, 0. Okay? From here, what I get is I can see that the rank of A is going to equal 2. And the null space of A is going to equal the span of the vectors 10/7, 0, negative 1/3, 1, 0, comma, 1, 10/7, negative 10/7, excuse me, negative 5/21, and okay. So notice that the dimensions, we've got two vectors inside of that basis for the null space of A. So the dimension of the null space of A equals 2, and that equals the nullity of A. Okay, then we have n, which is the number of columns. There, n equals 4. So the rank of A plus the nullity of A equals 2 plus 2, which equals 4. And that confirms for us the rank nullity theorem. And there it is. Okay, a couple things about this. Basically, the rank nullity theorem is in this incarnation is essentially saying, okay, what we're going to do is we're going to take the number of pivots, right? Because the number of pivots is the rank of A. So in this case, we've got 2 pivots plus the number of free variables, okay, and that's going to equal the number of columns, right? And the number of columns or the dimension in which the null space is in, essentially, okay? So essentially, we're going to say this here is the number of pivots in RREFA plus the number of free variables equals the number of columns. And that is basically the rank nullity theorem. Now, we'll be talking quite a bit inside of class as to how we use it, okay? And then it'll come up a lot when we start talking about linear transformations. All right, so we basically want to understand how this works. Rank nullity is going to tell us the rank of A plus the nullity of A gives me the number of columns in the matrix.